Of course. Well, the SDA, or Standard Design Approval, was a huge achievement for NuScale Power. What that represented was design approval for our 77 megawatt reactor design. That was a significant achievement, and actually our second regulatory approval. So it built off of our design certification approval, which licensed the 50 megawatt design previously. So what that means for the industry is effectively it's a de-risking mechanism. So instead of going into future deployment with a technology that the NRC may or may not accept, what it does is it provides a level of assurance because the design itself is already been approved by the U.S. regulator. And then looking more broadly, because the U.S. NRC is very well respected and known to be very rigorous, it gives us a good foundation to work with other regulators to take the technology abroad. And what we've seen is the U.S. regulators working with international regulators in an exchange of information so that they can enhance those regulatory reviews abroad. So it's a really good foundation, and it has really tested the system in the United States for deployment of the advanced reactors and shown where we need to improve the process, and we're currently seeing a lot of updates to the process as a result. So as I mentioned, we did start with a 50 megawatt as a basis for the foundation. And we, of course, as a company, learned a lot through the engagement with the US NRC on that first approval. So what we were able to do then is first start with an engagement with the US NRC on how do we enhance the regulatory process. One of the things about the nuclear industry, we love our lessons learned. So looking at what went well, what didn't, and together with the NRC, we negotiated a more efficient review process. A specific example, in the DCA, it was a 6-phase review. We were able to point out that since we were building on an already licensed technology, a 4-phase review would support a more effective review mechanism. That doesn't mean that safety or rigor of review was compromised. It was just recognized that some of the steps were a bit redundant. So that's one example of how we move forward. Specific more to the design, what we looked at was the margin in the design, the analysis, and we were able to show how we could increase the power without really eroding the margins that were already present in safety. Beyond that, we did make some enhancements for value engineering or economics, but overall it was really just leveraging margin that was already inherent in the originally licensed design. That's first started with that strategy, the regulatory strategy, and really knowing what it is we were trying to achieve. The decision to go with a standard design approval itself was big because that really does go to the company's commitment to mitigate risk. From there, we laid out a plan and started with early engagement with the regulator to ensure that that plan had a good alignment. As I mentioned in the example of the 77 megawatt, we had a lot of engagement on the enhancements of the process. So the regulatory strategy, and then by getting that buy-in from the regulator, but then looking internal and making sure our plans all supported that and we knew what work needed to occur. Specifically, a great example would be testing. As you can imagine, nuclear, we want to validate our claims, and so it was really important that we engaged the regulator on our testing plan, and that they were able to witness key tests and were able to audit that and see the results. We do have a facility here at Oregon State where a lot of the testing was performed to ensure the thermal hydraulic codes were validated, as an example. So it was really, that was an important step in that pre-application process and the review process to substantiate our overall outcomes. That's a great question. One of the things we really learned in our experience with US NRC is how to describe our safety case to a regulator. So maybe contrary to what is well understood, the NRC was very supportive of the idea of enhanced passive systems, advanced technology, but their framework itself dates back quite a bit and hadn't been updated. So while we were able to negotiate with the NRC to sell our safety case, it did require us having to think about it in different terms. And so when you look abroad, most of the regulatory framework is in a similar state to where the US NRC was when we started engaging. So we're very used to having to really articulate our safety case and to regulators. And I think that's a skill we really developed through that NRC engagement process that translates abroad and will help us in that area. Well, obviously, a nuclear safety culture is paramount. And I think there's a misconception that innovation and safety can be opposite ends of the spectrum. And in my experience, it's not true. In fact, a lot of the enhancements in our design are built off of enhancements in safety. So we didn't start with the regulations necessarily as the building framework for our design. We started with, let's make a safer design and then figure out how to navigate the regulations. So the innovation actually came from having to figure out how to make a safer design overall. So they actually can be reinforcing in one another as long as you think about it in the right terms. And in our case, that's what I've experienced, is the safety drove the innovative mindset. Yeah, I think there's a lot of opportunity for digital technology and use of tools like AI in nuclear to enhance reliability, maintenance frequencies, predictability, situational awareness. But of course, you do have to go back to how do you appropriately apply standards and oversight to advanced technologies. So it's important for us, we always start with that safety as a base mindset, and then what standards are correctly applied to that safety, and then move from there. A great example, I would think, is for digital technology, we did have our what we call HIPS. It's our highly integrated protection system. It's a fully digital system. Was one of the fastest topical reports we had approved by the NRC in original DCA time frame. So I think that speaks very highly of our rigor and our validation of safety and advancement and willingness of the NRC to accept that. We're very proud of our partnership with ENTRA1 and with TVA announcement. That announcement represents up to 6 gigawatts of NuScale nuclear deployment in the near future. So what that I think signals to the market, ENTRA1 as an entity brings financial acumen, development experience in the energy sector. TVA is a highly experienced operator. So that really shows a demand signal for new nuclear in a way that is revolutionary in this industry. This model is not really been used in the US, so I think it really is an innovative way to deploy advanced nuclear technology with strong partners that have their domain of expertise. Yeah, I think there's always a misconception that licensing does all the work. At least that's what I sometimes hear as a rumor. But it's really, a team effort, and that's actually something I really love here at NuScale is we are a team, and so my team could not do the licensing things that we've achieved on our own. We work integrally with engineering and our operations team from the early stages to ensure we understand where they're taking the design, the operational philosophy. We help identify potential gaps, ensure that we can develop those materials to support the regulatory safety case early. And that really supports the iterative process of having a design at the end that's not only safe, innovative, but licensable. But we definitely rely on an integrated approach with our teammates here in the company to make that happen. For those that are interested in working in the regulatory intersection, I think they should definitely make sure that they work on their technical skills. At the heart of what we do does come back to having a strong technical foundation. But I also think, and having an engineering degree myself, one of the things I never thought I would focus so much on is the communication skills. A lot of the regulatory work depends on being able to articulate that safety case in a way that other people understand. And engineers typically, while very smart, get very in the weeds of their technical case, and to audiences that don't understand the topic as much as themselves, it can be challenging. So I would say beyond just the technical, which is vitally important, I think honing those writing and speaking skills is also a good attribute. And then, of course, we do find ourselves spending a lot of time in regulation, so it doesn't hurt to spend a little time learning about the law. We aren't lawyers, although there are folks that work in that, but it does help. So the one thing I would also note, a lot of people do historically shy away from the regulatory area. I think there's a perception maybe it's not so much fun, it's very mundane. But what I will say is the one thing that a lot of people miss is you do get to work in a wide variety of topics. You can spend time working in electrical or the thermal hydraulics, the civil, the operations area. So you may not be a technical expert in that capacity, but you get to span a large variety of topics and get a really good appreciation for the integral nature of how all those things fit. And so it keeps the job very interesting. Oh, no, I guess I would just say, the advanced nuclear is something that personally I'm very passionate about. It brought me to NuScale. I saw an opportunity a long time ago to really solve a lot of the world's problems through technology like nuclear. And here at NuScale, many of us are here to drive the technology forward to really bring a better world. So I think the intersection of where we are is very exciting. We're seeing nuclear take off in a way I can only have dreamed of when I exited college many years ago. So I think it's a very exciting time to be in nuclear.